So I've got 3 bricks here, okay? 3 bricks. The 3 bricks represent ideas, concepts that build on one another, okay? We're going to look at scientific notation, which is this brick here, the one up the top. But in order to really get scientific notation, to understand it and be good at actually using it, we need to revise a little bit 2 other ideas which you're pretty good at, but I want us to jog our memory. So the 2 ideas are index notation. Index notation, that's when you've got like something to the power of something. We'll have a look at it in a second. We'll draw a table. Index notation. And the other idea is significant figures. Significant figures. We looked at these at the end of last term when you thought about rounding. Okay? So significant figures, index notation. Let's just really quickly review them, and then we'll build scientific notation on top of both of them. Okay? So index notation, let's just draw up a quick table, okay? 2 columns, doesn't need to be really wide. This is under index notation. I just want us to remember, what does index notation mean? And particularly, what's the difference between positive and negative indices? Okay, so this is what the table's going to look like. 2 columns. We'll call the left-hand column index 4. Index 4. And we'll call the right-hand column value. So we're going to write some numbers in index form and then think about, well, how big are these things? Okay. So index form and value. There you go. Okay. Now, rule a few rows here for me and leave them blank. We'll come back to them in a second. Probably 3 rows that are blank would be nice. And in this 4th row here, okay, let's write our first number in index form, write them all with the same base. I'm going to write 10 to the power of 1. Okay, 10 to the power of 1. Now the index, the power, what does it mean? What does the 1 mean?
It means 10 square root.
It means 10, right?
Times 1.
And I multiply it by
Times
itself.
10.
Yeah, just once. Just once. That's what the 1 means, okay? So 10 times itself, well, just once, really. That's just 10. Okay. Now, if I wanted to multiply it by itself again, 10 times 10, right? How would I write that? I'd write it as 10 to the power of 2 to indicate multiply it by itself once, twice. Okay. So that'd be 10 times 10. Its value would be 100, right? It's 10 times 10, yeah? It's okay. It's early in the term. I get it. All right. One more down the bottom. That'll be our last row. 10 to the power of 2. The next one will be 10 to the power of 3. Right? 10 cubed. So what's that? 10 by 10 by 10. We're multiplying, right?
3,000.
It'll be, this is 10 times 10. If I multiply it by 10 again, I'm going to add a 0 in the end, aren't I?
1,000.
It'll be 1,000. There's no 3's. Be careful. Okay? Yeah, 10 times 10 times 10. Okay? So, there's a couple of things to notice here. Number 1. How many zeros are there each time? How many zeros are there? Well, here there's 1 0, which corresponds to the 1, right? Here, you've got 2 zeros, which corresponds to the 2. That's kind of nice and neat. Easy way to remember. Here there's 3 zeros, 1, 2, 3, which corresponds to the fact that it's 10 to the power of 3. Okay, that's good. That's the first thing. The second thing is, we went down the table, right? And we kept getting bigger. As if we go backwards. We go up the table. We climb up. From here to here, I divide by 10. Can you see that? Going from 1,000 to 100. I divide by 10. Is that okay? Yeah? Not yet? All right. If I go from 100 to 10, I'm doing the same thing. Right? Divide by 10. So if I go up 1 more, what do you expect to be in that row?
0.
If I'm dividing, this is 10, and I'm dividing by 10, 10 divided by 10 is 1. Now, that's the right-hand side. Following this pattern, what would you expect to see here in index form? It goes 3, 2, 1,
0.
0. 10 to the power of 0. It's a bit weird, okay? Multiplying 10 by itself 0 times. But if you follow the pattern, you can see what's going on, okay? Let's follow the pattern again. Going up again, right? What's 1 divided by 10? We can write that in decimal, can't we? 1 divided by 10 would be...
Negative.
You can get your calculator out, it'll tell you, right? 1 divided by 10 would be a tenth, right? What's a tenth as a decimal?
0.1.
It's 0.1, isn't it? 0.1. That's what happened when I divided by 10. Following the left-hand side, I went 3, 2, 1, 0. What would be next? It'd be -1, wouldn't it? The numbers are going decreasing as you go up the table. Do you guys reckon you could finish off the top row for me? What would be the left-hand side? 10 to the power of -2, good, right? I'm going to divide by 10 one last time. Divide by 10. 0.1 divided by 10, that's 0.01, isn't it? It's even smaller. Okay? Right. Now, again, notice, right? A really helpful pattern for us. How many zeros were there here? There were 3. Matched up with this. How many zeros are there for this? There's 1, which matches this. How many zeros? None, which matches to this. How many zeros? There's 1 before the decimal place, which matches to that. And here there are 2, which matches to that. Okay, so you can see how many patterns there are in this table, right? Now, the reason why I've chosen 10 and not like 2 or 3 or 4 is because scientific notation, it uses these 10s. So this is actually going to be a really useful table for us to refer to in the future. Okay?